consists of two matrices. One of the matrices is called a design matrix, and one of the matrices is called a data matrix. And the design matrix is what you see in the upper part of the screen here. And here, this contains information about which samples do you have in your data and to which conditions do these belong. It can be biological conditions or it can be technical conditions. So in this case, you have one column with sample names and one column with which groups they belong to. And there are two groups, A or B. And the second matrix is the data matrix. And here is where you have all your measurements. So in this case, you have a table where you have, in this case, proteins in the rows, and you have sample names in the columns. So the 6 columns here to the right are the sample names. And so for each protein, we can have additional annotation columns describing which protein it is or other information that might be useful. And then in addition to this, we can have statistical contrasts. And so for the statistical contrasts, so here is an example. Let's say we have measured this protein in 12 times, so in 12 samples across 4 different conditions. So there are 3 replicas per conditions here. So from this we need 4 different values for OmicLoupe. So one is the average expression, which is the overall average. One is the log fold change, which is the difference in distance between the target measured groups. And then you have, this will give you a p-value, and you will also need to calculate an adjusted p-value, an FTR. So for each statistical contrast you use, you have this same base. In this case we call it comp, and this is used for all these 4 columns. And then you use these different suffixes. So in this case you have this log.fold change, .average expression, .p-value, .added p-value, as described above here. The final thing to note is that if you want to use multiple data matrices together, so you want to match 2 different sets of data, then OmicLoupe will need some way to coordinate these. And so then you have one column here. You need a column in your data matrix which is shared between these. So in this case we have one called the gene column, gene symbol, and this will match to this column IDX. But this is only needed if you use 2 matrices. So to recap, you need